So the Avonford Star's back on again. There's people ranting away. The trouble with young people these days is they watch too much telly, they sit there gawping and becoming steadily less intelligent. I challenge you to carry out a proper test. Okay. So here we have a hypothesis that effectively children are becoming less intelligent. So what we're going to do is we're going to set up a little hypothesis which is H0, and H0 we're going to have that, well, people are becoming less intelligent because they're watching telly. Well, I'm going to say first of all that, wait a minute, there is no correlation between IQ and telly. And then my alternative is what this guy's ranting on about, which is, oh wait a minute, there is a correlation, i.e. my product moment correlation coefficient is going to end up being less than 0. Now, what we're going to do, as per usual, is find some critical values, use those critical values, and then decide whether or not it is significant. So, you've got a couple of things that you can do. The first thing that you can do is find out actually is what the product moment correlation coefficient is, and then test it with the critical region. That's the way that I like to do it. So what I'm first of all going to do is find out my value of R. Now, obviously, I'm not going to necessarily write a load of stuff because this little table that we've got up here, actually you can put that in your calculator. And your calculator, you type in those, and the calculator will fill out the rest of this table bit here for you and chuck out these numbers if you know how to use it. Again, watch the video. So what I'm going to do is just copy and paste those numbers, because the skill here is not in copy, paste and move. Okay, let's try that again. Let's move a bit further down. There we go. So the skill is not just in filling out the numbers. You can do that. It's just a collector. The skill is in using it and interpreting it. So what I then need to do is find out the product moment correlation coefficient, and that is my value of R. So remember, R is Sxy over Sxx Sy and the square root of both of those. So I need to work out Sxx, Syy and Sxy. This, and you should know your formulas by now, sigma, can I do a sigma? I'm going to have to do that again. It's going so smoothly. Sigma x squared is not even any better, minus n x bar squared. Syy is sigma y squared minus n y bar squared, and this one is sigma xy minus n x bar y bar. So, this first formula, well in fact I'll do the last formula because I've got space underneath. Sigma xy, 6674 minus n. Now, how many people were there in the table? There was 6 or something, wasn't there? 6 people. So minus 6 times x bar, which is 10, times y bar, 112.83. I'll put the recurring in. Probably won't use it though. Then Syy comes out to be sigma y squared, and I'll pause it and fill it out right. So I filled out the rest. I've got Sxx there, Syy, Sxy. These are the actual answers for them. Obviously, I need to quote R again, quote the formula, put the numbers into the formula. It wasn't sufficient for me just to say, oh look, I can get this off my calculator. I actually wanted to put the formula in there. This is going to be my answer. Do bear in mind, you notice I put Sxx, Syy, I think I've mentioned it before. You don't have to, it can be the square root of both of them. Square root of 2 times square root of 3 is square root of 6. I just like to keep them separate for some obscure reason. So there is my value of R. Now what we need to do is we need to say, well hang on a moment, where on our values is this going to be suitable? So we're going from -1 to 1 with 0 having no correlation. And if you remember correctly, this is effectively where I wanted to accept H0. Let me go into blue. So this is where I accept H0, because I am saying, oh look, there was no correlation. So here I'll accept H0. My value is here, and my question is my critical region there, or is my critical region there? If it's on this side, then I'm going to reject H0 and accept H1. If it's the other side, well, it's still in the region I accept. It's just like we did with a binomial expansion in S1, and we have done with the other ones as well, Poisson 2. So here I need to find my little tables. And so here are my tables for the product moment correlation coefficient, so the R tables, page 21. Now, what I need to look up is, we're doing a test at, let me go back to the questions, I can't find it in front of me. It doesn't say, which means I'll do 5%. Generally speaking, they do say, if I remember correctly, but if not, I'll go down the route of a 5% significance level. Generally speaking, that's the one that I'm going to use most often. So, no, it really doesn't say. So, here's what I'm going to do. At 5% significance level, I'm looking in a one-tail test because I'm not looking at both directions. So there's my 5%, would help if I had a colour. There's my 5%. I had 6 children, so there's 6, and there is my value. Notice all the values in the table are positive, although actually I'm saying they're becoming less intelligent, so my critical value, because I think it's going to be less than 0, is going to be minus 0.7293. So this value here was minus 0.4, what was it, 425 or something like that? Yep, minus 0.425. I've just found from my table that my critical value is minus 0.7, I can't even remember it, how bad's that? 7293, 0.7293, which means if it's on this side, I will accept, on this side, I will reject. And so, I can accept H0. There is no correlation between watching television and the intelligence of children. And that's the conclusion, effectively, that I'm going to make. Remember, when you're making a conclusion, what you should have is not just a conclusion mathematically, I accept H0 and reject H1, or some, vice versa, reject H0 and accept H1. But you should also have the conclusion in context. So there's not enough evidence at the 5% level to justify the claim that there is a correlation between IQ and TV, and in this case, he claimed a negative correlation. Do bear in mind, there's a sample size of 6. It's not big enough. If you really want to make just proper justification, your sample size needs to be bigger. In this instance, we're just doing the maths, so hey.